Now we're going to keep going. We're going to work just tons and tons of examples because that's the best way to learn, right? So let's say I've got f of x is equal to 3 over x squared minus 2x minus 3. And I want to find the domain. And that's what all these problems are going to be. You find the domain. So here's two things that can happen. I want to either look for square roots, or I want to look for dividing by 0. All right, so this is what I'm looking for. So what do we have here in this problem? We have a dividing problem, right? Because we're actually dividing. So what do we want to do? We want to say we don't want to divide by 0. I'm going to write this over and over and over again because I hope that the more I write it, the more likely it is that you'll learn it and stuff. So we don't want to divide by 0. Cool. So here's the deal. That means that we have to set the denominator equal to 0 and exclude those points. So we want to exclude where x squared minus 2x minus 3 is equal to 0. So exclude. These are the open holes. If you're thinking about your number line, we want to exclude those points. Okay? So how do we solve this? Now, we did a whole chapter on it. Do you remember how we do this? Hi, Kitty. Solving this problem by, it's an F word, by factoring. All right, so let's factor this out. Got an x in the front, so these are x's. This number is negative, so we have a plus and a minus. Need numbers that multiply to get to 3 and have a difference of 2. So how about 3 and 1? Now, if you want to FOIL this out, first, outer, inner, last, that works out. So if you're short on factoring, better get there. I know. So now to solve for this, remember we said each one of these equal to 0. You can always go back and review the lectures if you're a little clumsy at this. There's no harm in it whatsoever. So x equals -1 and x equals 3. So we want to exclude those points on our number line. So here at 3 and -1, we're going to do open circles. And we're going to say, okay, this way, I'm going to include all the points except for those. I'm going to include all the points except for those. So I'm going to start off, remember I'm going to go from left to right, from -∞ to -1, from -1 to 3, and then from 3 to infinity. So now if you want, we can check our solution. We can go at, what do we have? We had 3 divided by, now you've got to have your parentheses in there. If you don't have your parentheses in there, something funky is going to happen. And something funky might happen anyway. Something like that. Oh, it was a -3. Come here, -3. -3. Graph. Alrighty. So here's your graph. Not like you can't see it already. Alright, so you see what we got here? You'll see that we've got this graph here, and we've got a hole, and we've got an asymptote going down here at -1. Yeah, I'll pull you over. Mess with it. No? No, it won't let me. Oh, I did it twice. I'm so fabulous. Oh my goodness, what happened? I lost my notes. Hold on. All right, I fixed it. All right, so we've got here at -1, we have an asymptote. And over here at +3, we have an asymptote. Okay? So again, we have a hole here, we have a hole here at -1, and then a hole at 3. Now, here's the deal. On your calculator might be doing something like this. Might be going, you might be seeing something that looks kind of like that has these big, ugly horizontal lines in there. If you see that, it's because you have an older operating system on your calculator, And instead of showing these, instead of leaving the space for those asymptotes, it's actually drawing them in, which is really stupid. And they fixed it on later versions, but if you have an older calculator, that might not have been updated. So just be careful. Be careful for that, so that's not something that you have to worry about. Okay. Let's see what else I have to say about it. The thing that you can do though is even if you have a funky calculator, that you can go and you can look at the table. So again, by looking at that table, second table, you can say, okay, well here at -1, I've got an error. And then here at 2, 3, I've got an error. So in these places where I have an error, those are the points that I need to exclude from my graph. Okay, so I'm sorry if you have an older operating system on your calculator. I don't know how to fix it, but something you can just be aware if your graph looks funky. Again, this is the other reason why we're solving it algebraically. Alrighty, let's try another one. Let's try f of x is equal to square root of 3x plus 12. All right, so what do we say about square roots? For square roots, I only want to take the square root. Oh, I spelled it out nuts. I only want to take the square root if the stuff inside is greater than or equal to 0. All right, so if the stuff inside is greater than or equal to 0. So this is what I want. All right, so this is very different. I want to make sure you understand the difference here. When we're solving these square root problems, this is what I want. When we're solving the divide by 0 problems, this is what we're excluding, okay? So make sure that you've got that difference. Here we're getting rid of points. Here we're saying, well, these are the only points that I do want. All right, so we've got 3x. Oh, I forgot. I'm going to subtract my 12 from both sides. So we've been solving problems like this in the whole last section, so now you know why we did that. So 3x is greater than or equal to -12. Remember, we don't flip the sign unless we divide or multiply by a negative number. We're not doing any of that here. So I've got x is greater than or equal to -4. So these are the only points that I want. I only want the points that are greater than or equal to -4. So you can remember how to graph that on a number line. Greater than or equal to -4. So I'm going -4 to infinity. And in fact, this is the domain of our function from -4 to infinity. And you can go ahead and you can confirm that on a calculator if you want. You can say, all right, I got square root of 12. No, so no, 3x minus 3x plus 12. 3x plus 12? No, it's not 12. That's a 12. 3x plus 12. And I'll graph it. And there you go. So you can see that we don't go past -4. So that confirms our findings. We can also look at the table and see if we go up to 4, there's an answer. But if we go anywhere past 5, we're not going to have an answer. So we're able to confirm what we did in real life with what we got with the calculator. So that's kind of fun. Let's try another. What about this one? F of x is equal to x squared minus 7x. About this one, what's the domain? All right. Well, here's the deal. The only two things we're looking for, remember, are dividing and we're looking for square roots. Do we have either division or square roots here? No, none of these. That means that our solution is all real numbers. We have no problem here. Our solution goes from -infinity to infinity. Just like when we did the parabola, wherever it went, way up here, a long time ago. We said the domain of this function was all real numbers, right? Well, if you go ahead and if you graph this, you can confirm it, but I just wanted to let you know that anytime you see a polynomial, any polynomial is going to be is going to have a domain of all real numbers. So you can even go in here and you can graph it. X squared, that's not what I meant. Let's try this again. X squared minus 7x. And when you graph it, you just got a really big parabola. Okay, so that goes off in both directions to infinity. So your solution, your domain of this problem is going to be all real numbers. Okay. Yay. Try another one. This is all you want to do for the rest of your life, right? So work lots and lots of examples. Something like this. Forgot my f of x. Once again, f of x is equal to 3 over x minus 7 plus 6 over x plus 6. All right? All right, so how do we find the domain of this? So how many fractions do we have? We got the division thing. I'm sorry, I thought that was kind of clear, but remember we're looking for square roots. We're looking for divisions, and that's supposed to be a division sign. So we have 2 fractions. So since we have 2 fractions, that means we have 2 chances to accidentally divide by 0. I say accidentally, I mean if we did it, we'd probably do it on purpose, but we don't want to. We have 2 chances to accidentally divide by 0, so we want to exclude both of them. All right, so look at each fraction separately. Got it? So let me look at this fraction first. So I've got 3 over x plus 7. All right. Now we said we don't want to divide by 0. There's my little division sign. We don't want to divide by 0. One day I will learn how to do that better. We don't want to divide by 0. So that means we want to exclude the points where the denominator, and we're only focusing in on the denominator, we want to exclude where the denominator is 0. So we want to exclude x equals -7, right? So we've taken care of that one. Now let's look at the other one. Okay, so now we've got 6 over x plus 6. And again, I'm going to keep writing it so that you remember we don't want to divide by 0, right? So we're going to exclude the part where the bottom is equal to 0. So we want to exclude x equals -6. Right, so to kind of summarize, we want to exclude x equals -7 and x equals -6. Got it? So drop our little number line, -6 and -7. So we're going to exclude these points, so we put an open circle on them. I'm going to go off. Everything else works. Everything works except for those 2 very, very specific points. Did I do something silly? Hold on. I did. Oh my goodness. Can we just pretend that this is a plus sign? Because see, like right here, I made it as a plus. Correct that. Pretend that was the problem I gave you. It doesn't really matter. I think you're getting the point. Probably thought I was crazy though. All right. So we're excluding -7 and we're excluding -6. So my domain goes from -infinity to -7, then from -7 to -6, and then from -6 all the way out to infinity. Cool? Makes sense now that I did it right? All right, so if we go in here and sorry about that. if we go in here and we graph this, we've got 3 divided by x plus 7 now, x plus 7, plus 6 divided by x plus 6. And if we graph this, let me zoom out. Zoom out over here a little bit, see what this looks like. It's not looking the way I want it to. Oh wait, yes it is. I'm just goofy. I can see it in my table actually right here. My table has an error at -7 and -6. I just can't see it because I'm zoomed out too much. So let me go back to the standard zoom. And, oh, that must be what's happening. It's really hard to tell. That's probably why I graphed the other problem initially. So that's maybe not the best example, but I can kind of give you an idea of what it's doing. This graph, in case you're curious, is actually going like this. So at -6 and -7, it's got these asymptotes. That's my elbow making funny noises. It's going to go down here, like that, and then up here, and then it's probably going like, yeah, that way. It's going like this in the middle. All right. So this is an example of why you need to be able to do this algebraically, because if you're just looking at this, I mean, I just accidentally glanced at the table and said, oh, okay, good, there's a -7 and a -6 going on here. But otherwise, you might be really hard-pressed to realize what's actually going on with this function. So we talked about the importance of solving this algebraically. This gives a perfect example of why. Okay. We'll try one more before we go on to the next topic. So say we've got f of x is equal to 1 over 6 over x plus 3 minus 2. We want to find the domain. So this is another example where we have two fractions. So we have two places where we want to avoid dividing by 0. All right. So I'm going to focus on, first I'm going to focus on this guy, because that looks easier. I don't want to divide by 0. I'm not going to actually write out this, I'm getting kind of tired. I don't want to divide by 0, so I'm going to focus on where the denominator is 0. And let me try this again. I'm going to say I'm going to exclude. I'm going to really write that word exclude, because I want to make sure you get it. I want to exclude where x plus 3 is 0. All right. So I'm going to exclude that. Now for the second one, I'm going to examine the whole thing. All right. I've already taken care of this one over here on the left, so now I'm just going to focus on the whole denominator. On the whole denominator, the entire fraction. And I want to exclude where 6 over x plus 3 minus 2 is 0. Got it? Got it? Maybe? I'm going to solve for x. So I've got 6 over x plus 3 equals 2. So to get rid of the x plus 3, hopefully, remember this, multiply both sides by x plus 3. Then these will cancel out. So I'll get 6 equals 2x plus 6. Subtract my 6 on both sides. Here, just making all kinds of progress. Divide both sides by 0. And not by 0. Divide both sides by 2. And get x equals 0. So in summary, I want to exclude x equals negative 3 and x equals 0. So I draw myself out a number line, 0 and negative 3, exclude. So I go open holes, go off to the left forever and ever, fill in the middle, go off to the right forever and ever. So to write this up, my domain is going to go from negative infinity to negative 3, negative 3 to 0, and 0 to infinity. Pretty sweet. All right, so that should be plenty of practice to get started with those. And don't worry, because we're actually going to do a whole lot more problems after this. Like, we're going to pretend to do other stuff, but really it's just an excuse to do more domain problems. So we're all super lucky today.